again, like I was saying, the vertex will have an x value of 2 because that's where the axis of symmetry is located. Now, in order to find the y value, you have to plug 2 into your equation. So I would have, let's plug it in this one just because that's the intercept form. I would have y equals 2 times 2 minus 1 times 2 minus 3. Okay? That becomes 2 times 1 times negative 1. So I end up with a negative 2. Okay, let's plot that point on the graph. 2, negative 2, right here. All right, next I want to know if it opens up or down. Well, because a is a positive number, so I'm just going to make a note, a is positive, I know that it's going to open up, looking something like this. If we take a look at our graph here, we can see the two x-intercepts and the vertex does in fact make the parabola open up, so it should look something like this. Just a side note, because it's in standard form, we know that the intercept is 6, so if you wanted to plot a point at 6 and have it cross through there, you could have done that as well. Now, domain and range. I've said this many times, but I'm going to say it again. Domain is always all real numbers, or negative infinity to positive infinity, because as it moves to the left and right, it will always be defined. It's the range that's restricted by the max or the min. Remember, range is the y value, and we need to go down to up. So the lowest y value I see in this case would be all the way down to negative 2, which would use a bracket, and it will go up forever towards positive infinity. Let's try number 2. Okay. Using the equation, which is written in intercept form, I'm going to identify a, which is negative 3, p, which in this case is a negative 1, and q, which is a positive 5. Essentially, you're doing a sign change for each of these because of the x minus p, x minus q in the general equation. The x-intercepts are the p and q values, so I have an intercept at negative 1 and 5. If you'd like, you can go ahead and plot that on here. Here's negative 1 here, and 1, 2, 3, 4, 5 is right here. The axis of symmetry, remember, exactly halfway between. So we could start at our intercepts and start working our way in and find our way in the middle, or you can just use x equals p plus q divided by 2. So we're averaging them. If I do that, I end up getting 2. So I'm just going to put a dashed line to represent my axis of symmetry on my graph. I'll label it as well. The vertex will always fall on the axis of symmetry, so I know that the vertex has an x value of 2 because that's what my axis of symmetry was at. And then to find the y value, I have to plug the 2 into the original equation. So that would give me negative 3 times 2 plus 1 times 2 minus 5. So that gives me negative 3 times a positive 3 times a negative 3. Negative and negative, so 2 negatives makes a positive, so 3 times 3 times 3, that's 27. Now, I know we don't have 27 on our graph if we're using a scale of 1, so it would actually be somewhere way up here. You could plot a point up here if you want, or when I graph it, I might make it just look something like this where I can tell it's going to keep going up. but we can't see it yet. Okay. It's going to open down because A is negative. Domain, like we said, is always going to be all real numbers. But the range, this time we have a maximum. So remember, range is the y values down to up. This function is going down forever. So I need to list that first as going down towards negative infinity with a parenthesis. The highest point on this graph would be at my maximum or my vertex, which has a y value of 27. So 27 would have a bracket since it is included. We're actually going to skip number 3 and go straight to number 4. Okay. Number 4, A is 1/2, P is 6, Q is 4. The x-intercepts, remember, are P and Q, so that'd be 6 and 4. And then the axis of symmetry is halfway between that, or you could just find the average of the two. The vertex has the same x value. To find the y value, we're going to plug that in. I'll write it over here. So I have 1/2, y equals 1/2 times 5 minus 6 times 5 minus 4. So that's 1/2 times -1 times +1, which would give me a -1/2. Because A is positive, I know it's going to open up, looking something like this. Okay, I'm going to plot all of this information on my graph so we can see the domain and the range. I'm an intercept at 4, 1, 2, 3, 4, and 6. I had my axis of symmetry at 5. The vertex was at 5, -1/2, so here. It opened up to look like this. Just a side note, because A was 1/2, we also had a compression. And I don't know if you noticed it or not, but for number 3, because A was 3, or excuse me, for number 2, because the A value was 3, we had a stretch. So I just figured I'd mention that real quick. And lastly, domain and range. Domain is always all real numbers, but the range here, we do have a minimum value. Down to up, the y value is -1/2 at the min, and it's going up forever. I know I went kind of fast through this one, but I'm hoping you're starting to pick up on the key ideas. I want you to attempt the homework today and then submit it so I can take a look at that. Next class, you are going to have a review over the 3 forms. And just so you know, we also have a quiz coming up. So just keep an eye on Google Classroom for details about that, and I will see you guys later.